Well, welcome back everyone. For those of you who are familiar with my channel, you kind of know what I do here. For those of you that might be new, I hope you stick around. My name is Mike, and my channel, as you can see, is called Build It or Buy It. And basically what I do is I fabricate different things, sometimes out of steel, sometimes wood, sometimes composites, usually for use here around the house and the shop. And then when I'm all done, I compare whether or not it would have been better to purchase that item versus buying it, and I do a cost breakdown and the whole 9 yards. So anyway, now that the holidays are over and things are slowing down a little bit, I'm finally getting started. Yes, finally getting started on the Gantry crane. So behind me here, we've got most of the materials. I'll do a quick walk around and show you what I'm going to build it out of. That I've been collecting. Most of the main frame is going to be made out of this steel pipe. It's almost 3-inch OD. Wall thickness on it is a full 1/4 inch, so it's pretty stout. The I-beam you see was originally going to be the I-beam at the top, but it's a little bit shorter than I want to span across the shop, because when I have it in the shop, I want the crane to actually be wider than the door. So when it's stored in here, I can still pull things in and out without having to worry about fitting past the framework. So that I-beam still just happens to be on the trailer. I'll use that for something else, and then I've got actually a little bit bigger piece of I-beam that's much longer outside that we'll use for the top beam. Over here on this side, that will be the upper portion of the frame that kind of has a piece of receiver tubing in it, so I can change the height because I want to be able to, if I take it outside, I want to be able to make it a little bit taller. And then over here is the casters. These are a little bit of an overkill, but I happen to have them. They actually came from my dad's place when he passed away. He had purchased some military surplus items, and one of the items he had purchased was an engine rebuild stand for a jet engine. I think it was actually off of KC-135 engines. So it had a big rotary frame, so just like any normal V8 engine or whatever, you could bolt it onto it and roll the engine around to do work on it. So those were the casters on that engine frame. So you can imagine that they're rated for much more than this Gantry will be rated for. They have a capacity rating on them of 15.0. So who knows? It doesn't say what that is. I'm going to guess that's either 15,000 or maybe 15 tons, probably not 15 tons, though they are very stout. They've got a double ball bearing on the swivel, double roller bearings in the wheels, everything is greasable. These are really heavy castings here, so I wouldn't doubt that the rating is way up there. The item there in the background, that I was going to use just a standard hand chain fall type hoist. But I picked that up on Marketplace, the trolley and the electric half-ton winch that's in really good, or chain fall that's in really good shape. It runs fine, the motor's nice and quiet, everything seems nice, and I picked that up for a really good price. I'll cover that in the price breakdown, so it'll probably have that on it instead of a manual chain fall. So that basically covers the material. So before we get going here on actually cleaning up some of this rust, let me take you over to the computer and I'll show you what the design is going to be. Okay, so here on my CAD screen, I've got just a 3D picture that I grabbed off the web of what many would consider a typical gantry crane. You have the I-beam at the top, you have this adjustable portion here that I talked about, and then most designs have that leg that goes all the way through with a crossbar here, and then a couple gussets to support that. Kind of a more traditional design, there's nothing wrong with it. However, as you guys know from my channel, many times I'll change things over what others have done just for my specific needs, and I don't like this design because this stuff can potentially get in the way. Let's say if you're going to pull an engine on a vehicle or something and you need to slide under with a creeper or whatever, this crossbar and stuff can have a tendency to get in the way. Not only that, it's just if you had a crane stowed somewhere, this would be an area where you could put some things, but with this crossbar you can't. So my design is not going to have any of this here, and some might think, well, it has to have that to have sufficient strength to keep these legs from spreading out. But there are plenty of, another picture here of this one's actually I think rated at like 4 tons. And as you can see, there's no crossbar here. This is just a tube that extends up and down. So they certainly, gantry cranes are made without crossbars in this area. Your steel or whatever your structure is has to be able to still support the weight. So I don't believe that'll be a problem on the design I'm going to do. So let me get this turned off. This is just a 2D rendering of what I'm going to do. One of these days I'll upgrade to the 3D version and teach myself how and get a little bit fancier drawings. But this gives you a view of how I'm going to accomplish not having any crossbars here. So these lines here depict that pipe I was showing you, and as you can see, it's kind of a truss or a scissor design, which will be more than sufficient strength-wise. If there was just one of these legs here, for instance, this leg here, if that was the only leg there, then as you push down on the beam, that means that this is going to have a tendency to try to bend this way, and it very well could. It would probably bend somewhere near this green line. And the whole thing would come down. But that's one advantage with a kind of a truss design, is for if this was the hinge point, which it would be, for this leg here to bend this direction, that means this leg here would have to get shorter. So when the forces are pushing this way, that puts this top piece in compression, which is, that pipe's plenty strong that way. Even if this up here was the hinge point and this piece here tried to bend out, that means this piece would have to get longer, so it's in tension. So by having this design, you counteract that bending force, and then these small pieces here and here, those are just like they would be on a truss in a house. They keep these from wanting to bow. So that will be kind of that effect here. There's the casters that I talked about. This dimension from that looks like it's about 73 inches. So this you could actually almost, if you're 6, I'm a little bit taller than 6 foot, but someone 6 foot could walk under this. I'll have to just duck a little bit. So that's kind of a nice height. Again, if you're going to want to work through this area or store things in here or get on a creeper or whatever. So this portion here is that tube. The blue is that tubing, piece of tubing that I talked about, and then it will have a piece of tubing inside of it. These small holes will be pinned for different heights. So this will be the fully retracted position, which actually will fit under the lowest spot in my shop, which is the tracks for the overhead doors. But then you could put, if you could extend it a little bit more, and that height there will actually fit within the ceiling height of my shop. It would hit the door tracks and those things, but if I'm working out in the middle of the shop, I could get an extra few inches there, and then you could extend it even farther up, even farther than that. So that's kind of the design there. The other view really doesn't depict much other than the piece of I-beam. This is a piece of it's 11 inch I-beam. The span between the two, as I mentioned, will be wide, a little bit wider than the door. My doors are 10 foot wide, so this will probably be like 11 foot in between. I haven't decided that 100% for sure. So that is kind of the lowdown on what it's going to look like when it's done. So wrap this up in here. We'll get back out in the shop and start cleaning up some of that rust. Okay, now that you've got kind of an understanding of the design, let's, as I mentioned, let's get to cleaning up some of the rust on this steel. I guess it technically wouldn't have to be cleaned off. I could just clean it off in the areas where I'm going to weld, but I will plan on painting this, so I don't need to get it all off, but I want to get the kind of the loose or the surface stuff off. So off camera, I tried a couple of different methods. I've got one of these. This style of this rust and scale removal, which is actually pretty good. You can put different drums on it. This one's the most coarse, and it was working, but until Eventually it would wear the curvature in here, which it would then work better. But right now it's fairly flat, so it kind of just does a strip. So even though it removes it, you got to spend a lot of time moving back and forth. So I just experimented with the DA with a 36-inch or 36 grit pad on it. And if this was the round portion of the pipe, I'll just do it like this. So I guess I'll film just a couple seconds of it, and then I will bring you back when I'm all done, because it's kind of like watching water boil. It's going to be pretty boring. And I did set up the hose there. The hose you can see here is for my dust collector, so that because it's going to create some rust dust. I don't want to breathe that. So. Okay, so that took me, I think, about an hour and a half to get through all those. Let me get you in here, give you a little bit closer view, because they obviously still look rusty. It's mostly just the dust after sanding them. So this one I cleaned off with some brake clean, and you can tell there's still some surface rust, but again, it won't matter. I just want to get rid of the bulk. Get rid of the bulk of the flaky stuff, so paint will stick good to that, especially with 36 grit. It put a little bit of some scratches in it. So I want to talk a little bit about the material itself. Normally I don't like fabricating anything with pipe. Not that pipe is a problem from a structural standpoint. From a shape perspective, it's plenty strong. It's just that with a pipe, if you're having whatever you're building has square cut ends, no big. But if you start to have miters, then that creates a little bit of a challenge as far as keeping the part, especially if there's miters on both ends, the orientation correct. As you can imagine, if you have a piece of square tubing or 2x4 or anything, and you cut 2 miters, you can lay the flat surface down, and that always keeps everything oriented. Because it's a round product, you can cut one miter, the first miter, and it's fine. But then if you flip it around to cut the other miter, because that pipe is round and can roll, it's just kind of a pain to keep that orientation the same. So what I'll do is I'll just build a little U-shaped piece of wood that it cradles in, one on each end. That way it kind of keeps it from rolling, and then I'll actually cut that wood cradle will have the appropriate angle on it that these need to be, and that way I can just set them the correct distance apart and use that cradle as a way to scribe the appropriate miter angle onto the piece of round. So I'm gonna go ahead and measure these up and make that piece of cradle wood, and then we'll probably, I could wrestle these up in the saw, but I think the angles are pretty severe on one of them. I can't remember exactly what the angle is, but it's more than what my saw will cut. My cold cut saw will cut a little over 45. But to cut it steeper than that, I'd have to kind of build a wedge piece to hold the pipe out from the fence. Probably more trouble than it's worth, so I'm just going to freehand these with the torch after I scribe the line, because it's going to get welded on anyway. I'll do a little bit of a weld prep on them after I cut them off. So let me get that wood miter box, for lack of a better term, cut, and then we'll start cutting, or we'll start marking these to length and getting them cut. Okay, so I got the channels that I talked about made. It's just some 3/4 inch material glued up into a channel shape. This fits the size of the pipe. Then from the CAD drawing, I was able to take the angles at each one of these intersections, transfer those onto these channels. I'll cut those miters in the table saw, or on the table saw. And basically the way it works is, once the miters are cut on this, I'll put one on each end. I have 2 of them. So one of them has the long angle, the other has the short angle. So I'll be able to put them on opposite ends of the piece of pipe. That will support it, hold in the same plane. These will already be cut, so then it's just a matter of taking a piece of soapstone or a Sharpie or whatever and transferring that mark onto the pipe, and then using the torch to cut it off. So I'll get these cut, miters cut on the table saw, and bring you back and show you how I mark them out. Okay, let's get back out to the shop and finish those up. As you can see, there's a little bit of snow in the background. Normally we would have a lot more than this. I live in a portion of the Northwest that typically could have several feet of snow by the time winter's over, and this is today's, I think, January 11th, 10th or 11th, and I've only had maybe total 5 inches fall. A lot of that's melted in between. We've had some rain, which is really bizarre for January. So anyway, let's get in the shop and get those, show how those miters are going to work out. Okay, we're here in the shop, as you can see, and I've got both of those cut. Just as I mentioned, it's still the channel shape, but it has the appropriate miter cut on it. So I'll pan you down here. I've got one set up on the piece of pipe just as an example. I've still got to do a little bit more accurate measuring on the pipes themselves to figure out how I can best maximize the use of material. But in a nutshell, I'll just ultimately clamp it on there like it is now. On the portions of these sides and the bottom, on the portion of that U shape, I can just reach in with the soapstone and mark that. But then across here at the top, I could have made this a box piece, or in a perfect world, I would have had a piece of wood or plastic or anything that perfectly fit this outside diameter. Could have cut that to a miter, but if it was round, then you're still back to fighting the issue with the pipe not being indexed. So I prefer the square shape, and it was just easier to leave it open on the top. I could have boxed this in, but then you'd have to slide it all the way down. So by being open on the top, it makes it easier to use, and to transfer this line, all you have to do is just have a nice straight edge that goes across both of those. And then I can, same thing, use that to scribe that line with the soapstone. Works pretty easy. So anyway, I think you can see that line there. I'm going to get these, I'll finish getting these measured out exactly where I need them to be. Some of the pieces, I'll try, we'll see if it works out. I got to think it through. If I have some pieces that are long enough for both to get two legs out of one. If you recall, since it's an A-frame or kind of a scissor truss design, two of the legs are shorter than the others. And to maximize the material as is so I don't waste it, I'll try to use both of these as an example. So if I cut the one miter this way, and then if you envision it flipping that around as a mirror, I'll use this other one kind of as an example, even though the angle's different. If you cut this one this way, that way one miter cut will give you both ends, and you don't have to waste the amount of material from here to here, versus if I cut this one off and there was a square cut here, then I'd have to scoot it over, start over with a new miter. This way you can use the same single miter can be used on two separate pieces. So I'll try to do that. If I have the material, I gotta lay it out and see where it is, because since the miters are different on the long one versus the short one, to have that overlapping miter, that would mean that both of those pieces would have to be a long piece or a short piece. And I don't know I have enough length in these to cut two long pieces out of one. So anyway, I'll get that set up, kind of figured up, and then bring you back and we'll start cutting with the torch. Got that top part marked out, but I've got to mark out the bottom, which is a little bit trickier to try to fit the soapstone under there. So I think I'm going to probably put them up on some risers, and that way it gives me a little bit more room. Initially, a person can say, well, just scoot it out off the trailer, which you can do, but then that also, if it's out here and unsupported, then that recreates that issue with the pipe being round. So I'm going to try a couple things here. I might scoot it out to where if these guides would have been a lot longer, I wasn't thinking about that when I made them, then I would have been fine, because I could have scooted the portion that I needed to scribe out here, and then it would have been supported on the other end. But it's a little bit longer than it needs to be, so I might try that. And also I mentioned I'm marking them out with soapstone, and because it shows up good on metal. And the other reason is, if no matter how sharp of a Sharpie you have or a pencil, you have the body of the pencil kind of gets in the way. So this joint right here is really hard to reach in there. So by using a piece of soapstone, I can take it and just grind it and then make it into a much thinner, pointier marking device than you'd be able to do with a Sharpie or a pencil. So let me kind of reset up here and okay, so there's what I did. I just did a combination of both, scooted it out on this end, put it on a riser block, the other end put it on a riser. Since I can't scoot that end out, I suppose I could scoot it all the way down, but the other end's going to be pretty easy to reach because it's not such an extreme angle. So I'll get down there, mark that other end, and then we'll get this one cut. Okay, I got them marked out, got the blocks off. Let me pan you down here and kind of roll it through its first full circle so you can kind of see it. It's a fairly large ellipse on this piece. This is one of the long legs at the top, so that's the most extreme angle. But you can see that ellipse is very nice and crisp and uniform, versus if you tried to just eyeball that, I mean, you could get pretty close, but it wouldn't be a very nice fit. One thing I do or have been doing of late, as my eyesight's not what it used to be. It used to be able to just run the cutting torch and follow the soapstone line, but that line, as the torch gets really close, it kind of blows that away. So I typically take a really thin, super thin cutoff wheel. This is less than 1/16 inch, and I'll just go along right where that soapstone line is, and then that way if you bump it or rub it with a rag or slide it on the table, it doesn't go away, and then that also doesn't go away when you're there with the torch, and it makes me follow the line a little bit easier. So I'm going to get that scribed in this one. I did scribe both ends, but I'm going to wait to cut the other end after I cut this. Then when I'll take one more measurement to make sure from the long point of this cut to the long point of the other cut is indeed what it's supposed to be. I measured it out before I marked it, but I only have one extra piece of pipe, so I don't want to make a mistake. So it's better to measure twice and cut once. So I'll get this marked with the grinder, and then we'll fire up the torch. So I guess if you're wanting to use this kind of technique at home and you didn't have a torch, I mean, you could do this with a cut-off wheel, skinny wheel cut off, and do the whole thing. It'd be a little time-consuming because it's a 1/4 inch thick material. So this is going to be the torch I had before. I had two torches. One, I had a Victor that I inherited from my dad that was probably 60s vintage, but it was the small frame model. It really needed to be O-ringed because it was leaking a little bit. And then I had an offshore clone that, again, you get what you pay for. So I picked up a full frame Victor. They don't make this model anymore. I think they discontinued it back in probably the 80s from what I could tell, but it was a new old stock, brand new in the box. The guy just had never used it. Picked it up on Marketplace for a really good price. So it's nice to have a full-size, brand new quality unit to use versus something offshore. So let me get you back here out of the way so I don't get sparks on the camera, and we'll get going. Man, I wish this was the old days when I was young and wasn't shaky. I could cut a pretty straight cut without guides or anything else, but not so much anymore. Kind of embarrassed to show you a close-up, but it is what it is. So that's what they make grinders for, right? So I'll grind it flat, that way it fits the flat piece of square tubing that it goes on, and then I'll come back, after it's kind of fitted, then I'll come back and make a back cut on it as a weld prep for place for the fillet. So I'll probably get this one ground, show you that real quick, and then I think I'm going to be at about a half hour. I've edited this video, which will work out about right, because again, you probably don't want to see the other 7 done, and then we will I'll bring you back when all 7 have been cut and fit. So get this one ground or cleaned up here, and I just made a quick V block there so it's not flopping around when I'm trying to grind it. Okay, let's take a look here. When I cut it with the torch, I stayed a little bit proud of the line so then I could kind of maybe a 64th of an inch. That way I could grind into the line. So, disconnected. So basically I'm going to just using this to make sure I've got it. The scribe line would have been a flat plane already, so this way, just as I grind into it, you can see there that fits up against that piece of scrap plywood good. So that's what they'll all look like when they're done. So again, I will get the other 7 cut, because as you can see it's a little bit time consuming, and I'll bring you back and then we'll start doing some layout. I did in the background, you guys probably picked up, I'm working on that trailer that I built the equipment trailer on, just because it's nice and flat. I do have that welding bench, but this is too big a project for that. So unlike on that trailer where leveled, I was taking a lot of measurements off of level, this one isn't that critical because I'm just using this flat plane, but I did go ahead and put the 3 jacks on the trailer, and so this trailer is nice and level now. So if I do end up using a level, everything will work out good. So I'll see you back in a few minutes. Okay, so I just finished editing some of that last video, and I am right at pretty much a half an hour. So that's what I try to keep it limited to, so you guys don't get too bored. So I think we'll cut it off here. I'll get those other 7 cut as I mentioned, and then the rest of it should go pretty quick. I'm hoping maybe 1 or 2 more episodes. So you guys know the thing to do. It really helps me out if you subscribe, like, and make comments, or if you got any questions. I try to look at them pretty regularly and respond to anybody that asks questions. So we will see you in the next episode.